a new module, and that module is on advanced dimensional modeling concepts. In one of the earlier modules, I discussed about the star schema and related concepts, and we did the grocery store data warehouse design using dimensional modeling. And in that, only the basic concepts were introduced. So as we move to other case studies, as we try to model different situations, we need to have some more advanced dimensional modeling concepts would be required. So we are now introducing those advanced dimensional modeling concepts along with along with very specific modeling examples. And in this module, we are also going to look at two case studies. One is the bank case study, and the other is an academic data warehouse. So these two case studies will also form part of this particular module, and we will be looking at several aspects of dimensional modeling, including changing dimensions, including mini dimensions and outriggers, including role-playing dimensions, including the time dimensions, right, and some more concepts which you would require to model different kinds of situations. So the first lecture in this module is on surrogate keys and changing dimensions. I have been mentioning about surrogate keys in the past, and I have given you some basic information about them. So in this module, we first need to talk about surrogate keys in detail, and then we look at what are called as changing dimensions and the role of surrogate keys in changing dimensions. So with that, I start this particular lecture. So lecture objectives include surrogate keys, their advantages, and how we generate these surrogate keys. And as I told you in the ETL, when we were discussing the ETL module, we talked about surrogate key generation and surrogate key pipeline. So all those you can relate to this particular lecture. Then we talk about changing dimensions, and we'll look at why we need to handle them and role of surrogate keys in handling changing dimensions. So these are the things that I'm going to discuss. All these complete slides are visible to you. Okay, so we first look at what are called as natural keys, and they are typically used in operational systems or the production systems, as we call them. And these are called as production keys. There are many different names given to them, say intelligent keys and also smart keys. And natural keys, we represent them by NK. Tell us something about the record they represent, and one very typical example is the bits ID number that we give to our on-campus students. So if you look at this particular ID number, it is not just an ID number or a unique identifier. It tells me so many things about the student. So let us try to look at what are these different fields that are there in this. So the first 4 digits or characters tell you about the year of admission. Okay. And B4 is the first degree, the first or the major, first degree we call it. Okay. A7 is the second degree. So we have this concept of dual degree. So, and these three, this 290, right? This number 290 is the ID number, actually the last 3 digits of the ID number, and this is kind of related to the merit position at the time of admission. Okay, so you need to look at this. So B4 basically, I think, stands for maths, maths, and A7 stands for computer science. Okay, so it tells me so many things about the student, that this student was admitted in the year 2003, and his first degree was maths. Then he opted for a dual degree in computer science, and his merit admission position at the time of admission was 290. So this is like an OLTP system, the natural keys in an OLTP system. Now in a data warehouse environment, we always talk about what are called as surrogate keys. And these are integer keys, so there are different kinds of names that are given to these keys: artificial keys and non-intelligent keys. So these are different names that are given to surrogate keys, and and they do not tell us anything about the record they represent, unlike the natural keys. Now, advantages of surrogate keys: it helps us in saving space, so we'll discuss that. And they allow us to do faster joins between the fact table and the dimension tables. So the joins are faster. Okay, so if I were to join these two tables, okay, then we have an advantage in terms of buffering the data warehouse from operational changes, and this basically refers to the reuse of natural keys in many domains, many applications, and allows proper handling of changing dimensions. So that is the other topic that we are going to cover in today's lecture. So let me talk about advantages, and saving space is one of the major advantages. I mean, not major, but yes, an important advantage. Surrogate keys are integers, and they are 4-byte integers, and these 4 bytes, so the question is 4 bytes enough, right? So it gives us nearly 4 billion different values, so that is good enough for all kind of applications. And so to get an idea, the total population is around 8 billion, right? It is not yet 8 billion, so half the population can be covered by these values. Now, for example, a data type occupies 8 bytes. Okay, so suppose there is a data type that you are using, and of say Oracle or any other RDBMS, it typically occupies 8 bytes, and there are suppose 10 million records in the fact table. So if I replace this data type, which is 8 bytes, to a surrogate key which is 4 bytes, and then there are 10 million records, so I save around 4 into 10 million bytes, which is around 38 MB of space, which is not much, but yeah, you're saving this much space. So what we do in fact tables is that we replace all the natural keys with their corresponding surrogate keys. So that's the first advantage. Second advantage is faster joins. So every join between a dimension table and the fact table should be based on surrogate keys and not on natural keys. So the reason we'll try to find out. So which is faster, comparing two strings or comparing two integers? So definitely comparing two integers is much faster than comparing two strings, right? And surrogate keys, as you know, are integers, and natural keys are typically strings. So now the third advantage, so when you perform the join, so let me take it back, sorry. So when you perform the joins, so if you did not have surrogate keys, you had to perform the joins based on the natural keys, and natural keys are strings, so you need to compare lots of strings for performing a join between, a dimension table and a fact table. So this would take a long time. Now, so comparing two integers would be much faster. So that's why the joins will be executed much faster. Now, buffering data warehouse from operational changes. So this is a typical scenario in a bank or in a telecom company, right, where inactive account numbers or obsolete product codes are reassigned after a period of dormancy. So I know that if this account has not been used for a long time, I would reassign it to some other customer, right? So these are problems, or these are situations that are common in many industries or many verticals. So you can also look at the telecom. So there is this concept of prepaid numbers, right? So if your number is inactive for a period of time, it is assigned to somebody else, right? So so this is not a problem in operational systems, but can cause problems in a data warehouse environment, right? So what surrogate keys do is they allow the data warehouse to differentiate between the two instances of the same production key. So what you have is that, so you had a natural key which was first assigned to somebody, right? And now it is the same key is reassigned to somebody else. So suppose this was SK1. So when I do this, so I'll assign it a new surrogate key. So that would help me differentiate that these two are different instances of this natural key, right? Not the same instance. So that's how surrogate keys help me in buffering the data warehouse, buffering the data warehouse from operational changes. So that is the advantage. So now handling changing dimensions. So this is the main topic that we are going to discuss, right? And so what are changing dimensions? So we need to address that, why we need to handle them, and how can we handle them. So these are three questions that we are trying to address. Okay, so first of all, let me come to okay, so before that, let me just give you some idea. So changing dimensions means if any attribute in any of the dimension records changes, that change has to be recorded. And in operational systems, as you know, like if there is a change, I will simply override that change, override the value and keep the new value. I don't care about what was the earlier value in most cases, right? So we don't worry about the old values. So in changing dimensions, any attribute value for any dimension record that changes is referring to a changing dimension. So why we need to handle them? It is important to know about what has changed in a particular dimension record, because it helps us analyze a lot of things about that particular dimension and the associated facts, right? So it is important to keep track of each and every change that happens in the operational system, so that we can do proper analysis. And how can we handle them? So this thing will come, this will handle them using the concept of surrogate keys. So let me try to explain this to you. So but before that, let me tell you about the different kinds of changes that we are looking at. So these are categorized into by the rate of change. So slowly changing dimensions, so that is the one that we are going to discuss today. And then there are rapidly changing dimensions when the rate of change is very high. And then we also talk about small dimensions and monster dimensions. So the simplest of these, so first let me clear this. So simplest of this would be small dimensions, and it is slowly changing. Okay, now and the worst combination could be rapidly changing monster dimensions. So rapidly changing monster dimension, it's the worst case, and this is in some sense the best case. Okay, and then any combinations of these four things is allowed. Okay, so the rate of change and the size of the dimension. So and in this advanced dimensional modeling module, we are also going to look at the worst case, right? That is monster dimension with rapidly changing dimensions. Okay, so both these things we'll be discussing. So we have now what are called as slowly changing dimensions. We call them SCD, and so today I'm going to discuss three approaches. Basically, type 1, so which is hardly used in a data warehouse environment, and the most commonly used is the type 2 change, where for every change in a record we insert a new record, right? And then we have type 3, which is a new attribute is introduced for any attribute that has changed. So if the department has changed for a person, so I'll now add a column saying that the new department. Okay, so that is type 3. So in general, type 1 and type 3 are not used often. Type 2 is the most commonly used approach, and then there are hybrid approaches. So this also we'll discuss, where we try to combine these two. So type 1 change, we overwrite old value, right, and used in cases where old values have no significance. and it is mainly used for error correction. Okay, and and spelling errors, say for example, and say suppose this is a record in one of the dimension tables, and this is the phone number, right? Sorry, this is the phone number, and suppose this has changed. So what I'll do is I'll strike it off and replace it with the new number. So that's what I do in type 1 change. And so some characteristics of type 1 change, they are fast and easy to implement. You don't have to do anything, just replace. Attribute values always reflect the latest assignment, because if my phone number has changed, so I'll just have the latest phone number in the system. No history of prior attribute values is captured, and in data warehouse environment can we afford to do that? So the answer to this is no, because data warehouse is supposed to maintain all historical data, and all the changes that happen in the data warehouse, in the operational system, must be captured in the data warehouse. So we cannot afford to actually use type 1 unless it is something that you require, right? So problems with this is that suppose this is the surrogate key here, then the description, then the department, and then the natural key. So what happens here is that history of attribute changes is lost. So if I make multiple changes to this, like say department, I keep on changing 2-3 times, but I would not know how it has changed, or how, from what was the earliest value, then what was the intermediate value, and now what is the final value. Only you would know the final value here. If there is any increase in the sale of the product, now this is a kind of a toy, IntelliKids is a kind of a toy which was put in the education department, educational toys department, right? Okay. So the management would not know the reason for increase or decrease in the sales, right? Aggregates over department have to be rebuilt. So aggregates will come later in the course, so we'll talk about that at that time. So suppose this is my thing. So what will happen is that I have, let's clear the annotations once. So you can see here, so the department has changed from education to strategy. Okay, and this is what I do. So I now have only one record. So this record is not there actually, and only this record is there. I've shown because I just wanted to show the changes. So only this record is there. This record gets deleted. Okay, so this is how we implement type 1 change. Now type 2 change, which is the most commonly used technique for handling changing dimensions. So what we do is, say suppose there is a record and one attribute in that record changes. So what I'll do is I'll introduce another record just below it. I mean, notionally I'm saying just below it, and make the change. So I keep both of them, right? So what it does, it allows you to keep track of history, and it is called as a new record approach. And now the connection with the surrogate keys plays a role, and this we cannot implement. This approach cannot be implemented without the help of surrogate keys. So let us see how this is done. Oops, sorry. So there's some animation related issue. I'll figure that out here. Okay, so you see there is a product, IntelliKids, and there's a surrogate key, this is a department, there's a natural key, right? Now what I do is so now see 2-3 things. So I have now seen that the department has been changed from education to strategy, and now you see that these two, the natural keys remain the same. So natural keys same. What has changed is the surrogate keys. So what I do is I generate a new surrogate key for every dimension record that changes. Okay, and here you can see this is a dimension table, and you can see here. So this is the surrogate key here, 1 2 3 4 5 6 7. This is the first name, last name, this is the marital status, and this is the natural key of the customer, and this is the surrogate key. So what I do is, now suppose my marital status changes from single to married, okay, and what change you can notice here is that this is the new surrogate key that has been assigned. Everything else remains the same except for the marital status. Customer number also remains the same, right? So this is how I implement. So there is a new surrogate key that is generated, and this is generated during the ETL phase. As we have seen, there are couple of subsystems which deal with surrogate keys. Similarly, here you can see that it was 1, 2, 3, 4, 5. Now it is 1, 2, 4, 6, 7. So new surrogate key has been assigned to this new record, but this natural key is the same. So what happens in slowly changing dimensions type 2 type of changes, that every instance of a record is captured, and these different instances are bound together by the natural key, right? So if I say select record or select star from this dimension table where natural key is ABC 922Z, so all the instances that are there, right, corresponding to this natural key would be listed out, and you can always order them with respect to the surrogate key. So the latest instance would be the last instance would be the latest instance. So this is how I implement, and you can see that after this change has been made here, say from single to married, any record that comes in the fact table would have the new value for the surrogate key, okay, and the previous records would match to the old values of the surrogate key, right? So this automatically does what it automatically partitions the fact table with respect to the instances of a particular dimensional record, right? And this again I have written the same thing, and what happens here is that well, let me clear the annotation, that adding the following columns help. So you can do what is, you can add a effective row here, effective date row, right? Okay, date, effective date, and then you can also have expiry date of that record, and also have the current row indicator. Sorry, what happened? So expiry, oh sorry, effective, expiry, and current row indicator, CRI. So suppose I made this change today, right? So what I'll do is, effective date would be so this is the change. So effective days will be today, so 27th May, right? Expiry, I'll just put it blank, and current record indicator I'll put yes, and here it will become no. Expiry will be today, 27th March, oh sorry, May, and effective day whenever it started, like say if I assume it that it was there from 1/1/14, okay, so I'll put that, okay. So this is how it would look like. So these dates help you in many ways. So advantages of type 2: automatically partitions history in the fact table that I showed you earlier, and customer profile is easily differentiated if I am talking about the customer dimension, and you can track as many changes as possible, and there's no need to build aggregates because the fact table is already partitioned, right? So again, we'll come back to this when we talk about aggregates in module number 7. Disadvantages: dimension tables can become big, because for every change you are adding a new record, and right, every change in a particular attribute of a record, right? So if there are lots of changes, then the size of the dimension table can become very big, and it does not allow association of the new attribute value with the old fact history and vice versa, right? So that's what you saw in the married to single to married status. So the old surrogate keys match with the old instance, and new surrogate key matches with the new instance, but there is no connection between the old value and the new old fact table values and the new customer values or customer attributes, and vice versa. right? So when we constraint on department is equal to strategy, this is with respect to the toy example that we were taking. We will not see IntelliKit facts from before the change date, because when I say department is equal to strategy, the latest surrogate key would be there in the dimension table, right? So only that would be taken up. And one more important point, that in the dimension tables, the surrogate key is the primary key, and we also keep the natural keys. So when we store both of them, because natural key, as I told you, binds the different instances of a particular record together, so we are actually taking up more space in the dimension tables, right? So then you may ask that how it would help us in saving space, right? So saving space happens only in the fact tables, right, or through the fact table, because this is where the maximum data is. Dimension tables, as you know, are small, right? So even if we have this additional 4 bytes, we add 4 bytes to every record in the dimension table, it does not affect, or the space requirement doesn't go up, but the savings that we get from the fact table by using surrogate keys is much larger, bigger than the additional space we take up in the dimension tables. And then we have what are called as slowly changing dimensions, type 3 change. So we add a dimension column. So basically what happens here is that suppose you have a value, okay, as a department, and you have a value, say department, okay. So now suppose it changes from education to strategy. So I'll have a new department column, right? And then I can also have with effect from WEF date with this. So we also call it the alternate reality, because it gives us both the current and the old value, right? Both current and prior values can be regarded as true at the same time, right? That's why we call it alternate reality. New and historical fact data can be seen either with the new or the prior attribute values, but this is not used very often, because unless you know that which attribute is going to change, right, and other attributes are not changed, not many attributes change, in those situations only we use type 3, but it is commonly not used. So this is how it looks like. So you can see so old department and new departments, so these are the two things. And any changes, suppose now it is changed from strategy to back to education, so then I'll have education here. I'll just strike off this and put education here, right? So I'll not know, so this would basically tell me that there has been no change in the department of this particular product. So type 3 is typically not used, and as I said, it is good for handling predictable changes and can lead to wastage of a lot of space, because if a particular attribute changes for one record, I'm adding a column, and you know that column, when you add a column, it applies to all the records, and myriad of unpredictable changes cannot be handled properly, and cannot track the impact, or cannot track the changes, intermediate changes we cannot track. Only the earliest value and the latest values are stored. So now once we have discussed what are surrogate keys and what kind of role they play in changing dimensions, let me come to the generation of surrogate keys. So initial historic load, like when you build the data warehouse, at that time you load the data into the data warehouse for the first time. So this is called as initial historic load, and it is very straightforward as far as surrogate keys are concerned, of course. And then when we talk about subsequent load, which is relatively complex. So subsequent load means when you periodically refresh the warehouse, okay, so at that time. So this is rather complex as compared to the initial load. So let me just give you a situation. So initial load, so there's a basic assumption here that we make, we say that the dimension records have been deduplicated. That means there are no duplicate records that exist in the dimension before it is ready to be loaded. So at the ETL phase, what it done is that I take the production key 1 and assign it a surrogate key 1. So it is not that it is product 1, so I'm assigning it 1 just for the sake of matching. I'm putting it here like connection. So surrogate key is 1, right? Then I look at the second record and I see found product key 2, product 2, and I assign it surrogate key 2, 3, and so on. Okay, so this is how what I do. So every dimension I'll do it like this. So I take the first record in the dimension table, assign it the surrogate key 1, go to the next record, assign it the surrogate key 2, and then keep on doing until I have done the complete table scan of the dimensions. So this is what we do. And in the initial load, when we now try to, so you have these, so suppose I had these 4 dimensions and the fact table in the center, right? So I'll load these dimension tables first, right? And now when the sale record would come, it would have all the production keys. So one would be like on what date you sold this particular product from this store, and this kind of promotion was in place. So I'll have all the natural keys in that fact table record or in that sales record. So what I do is suppose I get a fact record like this. So natural key 1, natural key 2, natural key 3, and natural key 4, and some facts are there, right? So what I'll do is I'll replace it by the corresponding surrogate key. Surrogate key 1, surrogate key 2, surrogate key 3, and surrogate key 4, and so on. So it also tells us about the order of load. Order of load should be that, because there are foreign keys, so these are all foreign keys going from the fact table to the dimension tables. So I have to first load the dimension tables, and once I've loaded the dimension tables, then only I can add the fact tables. Subsequent load, which is the refresh, which we call as the refresh of a data warehouse. So here what we do is data needs to be brought into the data warehouse, and old data may need to be archived, because after some time, once you have built the data warehouse, you cannot just keep on adding the data into the data warehouse. You may have to expunge some data or archive this data at some point, right? So we use this sliding window or rolling window protocol, which basically tells us that if I try to bring in a new time period data into the data warehouse, I'll remove the oldest data. So basically it is like this. I'll try to show you like this. So suppose this is my window. So it starts from 2000, 2001, 2002, 2003. Suppose this is the size of the window. Size of the window is fixed. Now I'm trying to bring in data that is for 2004. So I'll slide this window forward. So once I slide this window forward, so this 2000 goes out of the window, okay, and 2004 comes inside the window. So I'll have to basically archive this 2000 data. So this is how it works, the rolling window or the sliding window protocol, right? Every incoming natural key is to be compared with an existing natural key in the dimension table. So what we do is that I look at the first dimension table, and there are already records in this, and they will have both the surrogate key and the natural key, and the surrogate key is the primary key. So what I do is, now when the refresh happens, so I'll take the dimension table from the production system, which will have all the changes in it if there are changes. So what I do is I take the first record from this and compare it whether it is there in the, if it does not exist, so what I do is I simply assign it a new surrogate key, because there is a new dimension record that has come in. If it exists, so suppose I take a record from the production system, and if this exists, so I'll do a field by field comparison to make sure that this to check if there are any changes that have been made to this particular record. If if no change, so simply ignore it because it is already there in my system, and if there is any change, so assign it a new surrogate key using type 2 change, and that's how I handle it. So this requires a lot of efforts, right? So you have to first see what is the natural key of the incoming record, see whether it exists, right? If it does not exist, you have to simply ignore it, or you have to simply assign it a new if it does not exist, simply assign it a new surrogate key. If it exists, then you have to do a field by field comparison to see if any attribute values has changed since the last upload or last refresh, right? And if there is no change, so you simply ignore it. If there is a change, implement type 2. So that's what we do. And this is the surrogate key generation algorithm, and this figure has been taken from one of the Kimball's articles. So you have the original complete set of dimension records here. So this is a production key and the product description here, and what you have is original set of dimensional records. So these are now surrogate keys have been added, right? So this is the generation, this is generate surrogate key module, okay, and then I include this new surrogate key in the table, and then it goes to the database loader and it goes to the data warehouse. So this is pretty simple for the initial load. Subsequent load, so we introduce a concept of what are called as lookup tables. Okay, so what we do is dimension tables may have hundreds of attributes, right? And only a few records can be loaded in memory for comparison. So I have an incoming record, so I'll show you like this. So this is an incoming record, and this is my dimension table, and this is very wide. Wide means it has too many attributes. So incoming record has to be compared with each record to see if it exists or not, right? So since it is a wide table, so the record length is very high, so I can only add bring into memory a limited number of records, right? So that makes it more IO intensive. So what we do is we introduce what are called as lookup tables, where there is just a mapping between a natural key and the corresponding surrogate key. And since we are using we use type 2 change most commonly. So this is the latest assignment of the surrogate keys to a given natural key is mapped into this table. So this is how it looks like. So so this is for a dimension. So let me clear this annotation. So this is for a particular dimension, say product dimension, and after the initial load it would look like this. I'll have production key and the surrogate key, and there are only two records in this lookup table, so we call it LUT, okay, for the product dimension. So this is like this, right? Now suppose what happens is so okay, so let me first come to this table. So now suppose there are some changes in product 1 at a subsequent thing. So what I have done is, you can see here it is 6, earlier it was 1, so I have changed from 1 to 6, and new surrogate keys has been assigned, and in the lookup table there will be 6, right, not 1. And in the dimension table, so you will have product 1 and surrogate key 1, and you will have product 1 and surrogate key 6, right? So and 6 would be the latest one, okay. So that's how it is done. So makes generation of surrogate keys faster, because I need to do a lookup. So instead of going to the dimension, I go to this mapping table, which has only 2 records. So more and more records can pack into a block for comparison. And refreshing a dimension table speeds up because of this. Populating fact tables also becomes faster, because when you load the fact table records, so you need to find out what is the latest assignment of surrogate key, latest instance of that record, and that corresponding surrogate key only has to be used, and it always points to the latest dimension record. So all these are like advantages of lookup tables, and they are very, very useful. So for every dimension table there will be a lookup table. Order of load I have already discussed because of the foreign key constraints. Since fact tables have foreign key references to the dimension table, so dimension tables have to be loaded first, okay, and then the fact tables. Fact table loading, and as I told you earlier, only replace the natural key with the surrogate key. and this is how a typical lookup table looks like. So these are all the surrogate keys, which are strings, and you can see this is the latest assignment of surrogate keys. And let me clear the annotation. So this is now the subsequent load surrogate key generation logic, which I have already explained to you. So this is given in a flowchart kind of a module in a form. So incoming dimension record. So you start here and test if unknown production key. Unknown means it is not there earlier. So if it is yes, so generate a new surrogate key. So this part is pretty simple here. Okay, if it is no, right, so then what we do is get current surrogate key from the lookup table, and then do a field by field comparison, get the existing record using the lookup table, do a field by field comparison, and use poly to decide update strategy if something has changed. Okay, so if something has changed, some change is detected, so you use type 2 change. Type 1 is typically not used, right? So, and then once you have done this, generate new dimension record with new surrogate key, then you go to the database load. So this is how you do the refresh, and you can always parallelize the the comparison part of the incoming dimension records with the existing dimension records. So I can do I'll clear the annotations first. So you can see current time key. So this is a time dimension, this is a product, this is a store, and this is a promotion. So I can do it 4 different ways. So 4 threads can be assigned, and 1 thread is responsible for 1 dimension, and that way I can parallelize this. So this is nothing new here. So now in today's lecture we have looked at surrogate keys and its role in data warehousing. So we have seen that it has got many benefits, including saving space, faster joins, protecting the data warehouse from operational changes, and that is used for implementing changing dimensions, right? So we have looked at 3 types of changes, change strategies that we implement. Now we have 4 more, so which are called as type 4. So here we basically mean that we add a mini dimension. I'll not introduce what a mini dimension is, but just let me just enumerate. Type 5 mini dimension and type 1 outrigger. So the new concepts, dimension modeling concepts, I'll just highlight them. Outrigger, mini dimension, which are similar in some sense, but also there are subtle differences. And then we had type 1 attributes to type 2 dimensions. Okay, so we'll discuss this. And then we have dual type 1 and type 2 dimensions. So these are 4 other strategies for handling changing dimensions, and which will be covered in the next lecture. And mini dimensions and outriggers are 2 new modeling concepts that we'll introduce in the next class. So with this I wind up today's lecture. Hope you enjoyed.